This is the fuse and MCB characteristics trainer kit. Here we are going to study the characteristics of fuse, this KitKat fuse, MCB, this one, and bimetallic relay is inside this one, and ACB, air circuit breaker. So this is the AC and DC power supply, and this is internally connected to this one. This is AC DC current measurement panel, and this is the voltage, variable voltage and current injector panel. So here we can inject the variable voltage as well as current in the experiment when we perform the experiment. And this panel is overcurrent measurement and time elapsed time counter. This is also overcurrent measurement and elapsed time counter. This one we can use for fuse, MCB, and this bimetallic, and this one we will use for air circuit breaker, ACB. So in this experiment, and this panel is used for current detection. When there is no current flowing through the circuit, this LED will glow. So this is a Hall effect current detecting circuit. This one is Hall effect current detecting circuit. So this will detect the flow of the current, and when there is no flow of the current, that is zero current is flowing through the circuit, this LED will glow. So in this experiment we are going to find out the characteristics of the fuse, MCB, bimetallic relay, and air circuit breaker. Characteristics means the current injected or the current we have set to the we have supply current versus the time of trip of this burning of this fuse, or tripping of this MCB, tripping of this bimetallic relay, or this air circuit breaker. So we will take around 10 readings and we will plot the characteristics, that is current versus tripping time. So let's start the experiment.
In this experiment, we will observe the characteristic of a bimetallic relay. For studying the characteristic of a bimetallic relay, we have already connected the circuit as per the wiring sequence given in the lab manual. After connecting the wiring sequence, we will turn on the power supply, then check if the dimmer is in the minimum position. After checking the circuit connection, we will turn on the MCB. After turning the MCB on, we will set the current to 5 ampere for the first observation. Before setting the current to 5 ampere, we have to check the bypass switch is in the left position, that is open. Then push the start button and set the current to 5 ampere. After setting the current to 5 ampere, we have to push the stop button and wait for the relay to cool down for 2 minutes. Now we will push the start button. As we push the start button, we will close the bypass switch simultaneously. After some time, the relay will trip. As the relay trips, this LED indicates that the circuit has tripped and the current is 0. Now we will note down the time in the elapsed time counter, and for other observations we will increase the current and observe the time similarly. In this experiment we will observe the characteristic of the fuse. For the experiment, we have already connected the circuit as per the wiring sequence given in the manual. After connecting the wiring, we will turn on the MCB. Here the given fuse is rated 5 ampere, so we will give the current more than 5 ampere. To set the current more than 5 ampere, we will push the start button and turn this dimmer to set the current. We have set the current to 7.5, then we will push the stop button. We have set the current for 7.5 ampere, and now in order to observe the elapsed time, we will press the start button and close the bypass switch simultaneously and wait for the fuse to blow up. Now we have observed that the relay indicator is lit, and this indicates that the relay has tripped and the fuse has blown up. For another reading, we have set the current to 10 ampere. Now in order to observe the elapsed time, we will push the start button and close the bypass switch simultaneously. Now the fuse will blow in few seconds. This LED indicates that the relay is tripped and the fuse is already blown. In this experiment, we will observe the characteristic of the air circuit breaker. First, we have connected the circuit as according to the wiring sequence given in the lab manual. This is the ACB. The ACB is also connected to the panel. Now we will see if the dimmer is in the minimum position. Then we will turn on the 230 AC supply. This is the MCB for the 230 AC supply. After turning on the 230 AC supply, we will check if the ACB is in on position. Now this shows that the ACB is off. In order to turn on the ACB, we will rotate this manual lever by 90 degree in the anti-clockwise direction. Then again turn this lever 90 degree in the clockwise direction. Now this shows that the ACB is on. After the ACB is turned on, we will check if the bypass switch is in the left side, that is in the closed position. In order to set the current, we will push the start button and turn the dimmer to the desired current. We will set it for 10 ampere. After setting the current to 10 ampere, now we will push the stop button and then push the reset in the elapsed time counter. Again, we will push the start button and wait for the ACB to trip. For another observation, we will push the start button and set the current to 16 ampere. Then push the stop button and then push the reset button on the elapsed time counter and wait for the ACB to trip. Now we will push start button and wait for the ACB to trip.